Okay, then next I'm going to derive a rate constant equation for this type of reaction where the reactant reactants are different, or the reactant concentrations also will be taken. It's not same. The concentration of A and B will not be same at any time. So the reactant concentration will be different, or will be different, and also they are not same reactant, they are different reactant. So I'm going to derive rate constant expression for this type of reaction. It is not actually same. If you look at their rate equation, they are not same, right? This is concentration of A power 2, this is concentration of A power 1, concentration of B power 1. So I'll take this rate constant to derive a rate equation. I'll take this rate equation to derive a rate constant expression for this type of reaction. Let me proceed. Minus dA by dt equal to minus dB by dt equal to d product by dt, concentration of product equal to K concentration of A, so this is square bracket, and concentration of B. Let me see. A is reacting with B, that gives product at time t equal to 0. At time is 0, right? 0 minute, 0 time, that the reaction is not started. You have just taken A and B, you have mixed it, that's all, but the reaction is not started. The initial concentration product would have not been formed, therefore it is 0. The product concentration is 0 at 0 time. Let me take the initial concentration, that the concentration of A is A mole per liter, and the concentration of B, the product B, is B mole per liter. At time t, after some time, let me assume X is X mole per liter of product is formed. Then the remaining will be, the unreacted A will be A minus X, and the unreacted B molecule will be B minus X. Now I'm going to use I'm just at time t, you just, this is rate equation, you just write minus d concentration of A, reactant A at time t is A minus X divided by dt. So this is the rate with respect to A is defined equal to minus d concentration of B at time t is B minus X divided by dt, and equal to d concentration of product is X at time t. At time t, concentration of product is X, so dx by dt equal to K, concentration of reactant A is A minus X, and reactant B is B minus X. Okay, you can take any two pair. Either you can use this or this rate expression to derive rate constant. So I'll take this last two. This is dx by dt equal to K A minus X and B minus X. Okay, that's all. I'm going to now integrate this equation. This is rate equation. I'm going to integrate after rearranging it. A minus X. These two terms are taken to the left side of this equation. dx k and dt. Okay, I just rearranged it, and you different integrate it. Integration of a minus x and b minus x dx equal to k integration of dt, right? How will you integrate this? uh, this can be written, this can be, this term can be written, this equation is splitted into partial fractions, right? You learned it, you allied mathematics, that this equation is splitted into a partial fraction. So if you split, this can be written as a minus b 1 by b minus x minus 1 by a minus x. Okay, you just cross multiply it. You take LCM and you multiply, you will get back this equation. Just do it by yourself. Okay. Therefore, therefore I'll write 1 divided by a minus b, 1 divided by a minus b, and 1 by b minus x. This is minus 1 by a minus x and dx, right, equal to k integration of dt, right? Okay, then you will take, this is a and b are initial concentration, therefore it is constant, and the integration of 1 by b minus x, you multiply dx and introduce integral to both the terms. I'm taking out 1 by a minus b. Okay, I'll get integration of a minus x and dx. So now it is simplified, k integration of dt. Now you carry out integration of 1 by b minus x with respect to dx, with respect to x. The same way as we have done. If you integrate the same formula, x power n dx equal to x power n plus 1. Oh no, sorry. This is integration of 1 by x dx form. This is natural logarithm of x. Integration of 1 by x dx will be natural logarithm of x. Therefore, if you integrate this, natural logarithm of b minus x. This is not x alone, b is there. So differentiate this with respect to x and write in the denominator. So 0. B is initial concentrations become 0. Minus x, if you differentiate with respect to x, will become minus 1. And here, if you differentiate integrate, you will get logarithm a minus x divided by minus 1, right, equal to k t. Then I'll introduce integration constant c. Then this is minus, this is also minus and plus b. So for logarithm a minus x, this is minus b minus x. Okay, I'll simplify. This is log a minus log b. So log a minus b. Now I'm going to evaluate, find out integration constancy. The same limits are used. When time t equal to 0, x is 0. No product is formed. If you substitute here, I'll get 1 by a minus b logarithm a, x is 0. Here x is 0, so a by b equal to, this is k into t is 0, so this becomes 0, and this is constant. As substitute c in the equation, I'll get a minus b logarithm a minus x by b minus x kt plus 1 by a minus b logarithm a by b. Okay, just take this term to the left side of the equation. Minus, this is plus, minus 1 by a minus b logarithm a by b equal to kt. Now 1 by a minus b is common, so I'll take it out. Oh, sorry, sometimes. Okay. This is a by b kt. Wait. 1 by a minus b, this is log a minus log b. This can be log a by b, log a by b, that is a minus x b minus x, divided by, this is log a by log b is a by b. And now this is 1 by a minus b. This is b into a minus x, a into b minus x equal to kt. So if you, the expression for k equal to, you take this time logarithm, if you convert, okay, I'll do it step by step. You take t this side and a minus b. Okay, I write the next page. That 1 okay, is it 1 divided by t a minus b, right? 1 divided by t a minus b, and logarithm b a minus x and a b minus x equal to k. So you can convert, this is logarithm base 2 to base e, and you convert this into base 10. You'll have to, I should multiply it with 2.303 t a minus b logarithm b a minus x and a b minus x. Right, so this is the rate constant equation. Rate constant, expression of rate constant of second order reaction of this type when a b, when both the reactant are different, and also their concentrations also different, right? When the concentrations are different and also both the reactant are different, then the rate constant expression is given by this equation. Okay, then I must speak about okay, then we will convert this both rate constant expression to straight line equation and we plot. I'll do it in next video.